Okay, in this video we're going to go over how to add and subtract radicals, but sometimes those square roots, those radicals, will not have like terms to start. Let's see what that's all about. So in letter A, the instructions for all of them say simplify, and in A it says 4 times the square root of 3 minus 5 times the square root of 27. As it stands, we cannot combine these terms because the square root of 3 is not equal to the square root of 27, so these are not like radicals. However, even though we cannot reduce the square root of 3, it does not have a perfect square that goes into it. It's in simplest radical form. The square root of 27 has a perfect square of 9 that goes into it. So, moral of the story is reduce radicals or simplify them as much as possible first, and then see if you can simplify. It's a good rule of thumb for all radical problems. So, we've got the 5, so that's going to be minus 5 times the square root of 9 times the square root of 3. And that's what's going on mentally in the noggin. And then 4 root 3 is just hanging along for the ride for now. Well, square root of 9 is 3. So what we're left with here is 4 times the square root of 3 minus, now this is going to be 3. So this will be 5 times 3, which is 15. So that square root of 9 just became 3. Oh, and look what happened to come out of this. Now we have like terms. 4 times the square root of 3 minus 15 times the square root of 3. 4 root 3's minus 15 root 3's would be minus 11 square root of 3's. And if you're having trouble with that last step, watch the previous video that goes over how and why we can add like radicals. That's it. Pretty sweet. Let's keep going. So in B, we've got two radicals, root 8 and root 50, neither of which are in simplest radical form. We know that because 8 has a perfect square of 4 that goes into it, and 50 has a perfect square of 25 that goes into it. Let's reduce them and see where that leaves us. So this becomes root 4 times root 2, and 50 is root 25 times root 2. Ah, I hear some root 2's in there, and I see them. Root 4 is 2, so you're left with 2 times the square root of 2, plus root 25 is 5, so it's 5 root 2. And now we're left in a similar situation to here where we have like radicals. So keep rolling with it. 2 root 2's plus 5 root 2's, or 2 root 2 and 5 root 2, is 7 root 2. And that is in simplest radical form. So the moral of the story again, reduce and see where it leaves you. You don't have to see right away that they're going to add up. We'll end up there. If you do see it right away, that's pretty gnarly. Okay, letter C. We're going to do the same thing. All I've done now is extend this to include one extra term. So I can reduce 20, so that's going to be 5 times the square root of 4 times the square root of 5. 4 is the biggest perfect square that goes into 20. More on that in a second. Actually, you know what? Let's continue with that. Let's reduce it all the way. Root 4 is 2, so I'm doing 2 times 5, which is 10 times the square root of 5. So this has now been reduced. Root 15 has no perfect square in it, so it is in simplest radical form as is. And then you have 7 root 45. That can be reduced. So it's still going to say 7 minus 7 times 9 is the largest perfect square that goes into 45. So that leaves us with root 9 times root 5. Root 9 is 3. So you're essentially doing 3 times negative 7 is negative 21. So you get negative 21 times the square root of 5. So from here I look at this and I see, are there any like radicals we can combine? Yeah, 10 root 5 minus 21 root 5 is going to be minus 11 times the square root of 5. So those are checked off, but that leaves us with this unlike radical of root 15. So that's just hanging out, no way to combine it because it's in simplest radical form. Nice. I put a bonus one down here with 4 terms in it just so you could see what happens when we reduce and we have several like radicals. We can handle it no problem. So here you have 8 times the square root of 12. That's going to simplify to 8 root 4 times root 3. So keep reducing it. Root 4 is 2 times the 8 that's there is 16. So you get 16 times the square root of 3. All right, so that's done. Now let's go to the 75. Well, the largest perfect square that goes into 75 is 25. So that's going to be root 25 times root 3. Root 25 is 5. So that's going to be minus 5 times the square root of 3. Nice. From here, we've reduced that. Let's keep going. We've got root 18. Well, root 18's biggest perfect square that goes into it is 9, so it's going to be root 9 times root 2. And again, I'd expect after a little while, you might not have to do this step, and you can just go straight from here to here, and here to there. That's the eventual goal. I'm just showing what's going on mentally. Root 9 is 3, so we have 3 root 2. Here, we got root 32. The biggest perfect square that goes into 32 is going to be 16. So it's 16 times the square root of 2, or root 16 root 2. Root 16 is 4 times 6 is 24 with the root 2. Ugh. It's a lot of simplifying, so if you haven't already gotten good at simplifying radicals, I suggest you work on that. This is going to exercise that skill immensely. Now we have a bunch of like terms. 16 root 3 minus 15 root 3. Apparently I like 11 in this video. It just happened to be the number that we went with. Negative 3 root 2 plus 24 root 2 is 21 root 2. Another number I like. And we're in simplest radical form. You cannot combine those because we have root 3's and root 2's, completely different radicals. That's it, peeps. Reduce those radicals, then see where that leaves you in terms of combining like terms.